Good morning, everyone. Welcome to this webinar, Breaking Barriers in Plus Energy Building Design, Insights from Frontrunner Projects, right? I hope you are all having a good day. And we, from our side, are very excited today because this webinar serves also as the launch of the PEB HUB, which we've been developing in these past years and is part of the Horizon 2020 project Culturally that we will be explaining you briefly later on. My name is Beatriz Pineda. I'm a researcher at RMIT Europe, and together with my Culturally colleagues, Ana Maria Belleri and Marta Candidi, we will be your host for today for the webinar, and we'll guide you through the webinar and the slides. And we are also very pleased to have with us today 4 committed designers, so 2 architects, Ringo Offerman from Bombao Studio and Maria Cantalay Piedra from Ur Atelier, and 2 engineers, researchers, Herman Leys from SIS Energy Plus and Raúl Siria from CENER. So they will be later on during the panel discussion sharing with us some of the challenges as well, some of the lessons that they've learned in this journey, right, of building a plus energy building. And I hope their insights will be useful for you, for the attendees, for the audience today. And let me see if I can click on the next slide. Yeah. So these are our faces so that you can also see who is speaking. And we'll be, as I said, Ana Maria, Beatriz, myself, and Marta will be your host today, guiding you through the webinar. Before we start, so these are some of the housekeeping rules for webinars. So I know you are aware of this. So microphones mute, please, cameras off. And if you have any questions, please type them in the chat and we will have a Q&A at the end of the webinar. And the webinar will be recorded and the recordings will be made available at Culturally YouTube channels later on for you to see and to review. I see, Herman, you are not following the housekeeping rules. If you can mute yourself. No, I'm joking, but please, thank you. So I think, we'll be having this webinar structure so that you see what we are heading towards. So Ana Maria will start presenting the designer's guidelines, which are the 7 principles that we've found in our project in Culturally. And then I will guide you through the Plus Energy Building Hub, so the repository, and I will be showing you the platform, how it looks like, how you can use it. And finally, Marta from ACE will present the interest group on Plus Energy Buildings in the ACE Hub. So then we'll have the panel discussion followed by Q&A, as I mentioned, and the panel discussion will be gravitating around these 2 questions. So what are these main challenges in designing a plus energy building, and how can this repository, right, the PEB HUB, support PEB professionals in this in this journey of building a plus energy building? Then we'll have 2 presentations, short presentations by our designers today, and they will tell you all about it later on. So we'll go through that later. And without further ado, I leave the floor to my colleague Ana Maria, who will start presenting the design guidelines.
Yeah, good morning, everyone, and thank you, everyone, for being here. This is the latest event of Culturally project, which is a project, an Horizon 2020 project that I've been honored to coordinate as a project coordinator. It started back in 2019 and it lasted almost more than 5 years, actually, almost 5 years. 8 million budget, and the main aim of the project was to make plus energy buildings, multi-family residential buildings, let's say, viable. So the focus of the project was to reduce the cost. And as you can see in the next slide, sorry, well, I will show later. What is a plus energy building for us is an energy efficient buildings that produces more energy than it uses. And of course, the energy produced is produced from available renewable energy sources on site. And this whole balance should be matched within a time span of 1 year. We don't call it positive, but rather a plus, because we believe that it is plus energy buildings are more than positive energy buildings, because they reduce, they're able also to provide the building flexibility and reduce the load on the energy grid. They are able to share energy with the with other buildings if needed, in order to make also possible for example, historic buildings or retrofitted building that cannot reach that net zero energy balance. They can be somehow supported by plus energy buildings, and also they should have the lowest greenhouse gas emission possible. And on top of that, also provide an added value for the final users in terms of comfortable and healthy indoor environments. So this is the concept of plus energy building that we draw together with the project partners along the project. And please, Beatrice. So that's the next slide. This slide will show a bit of history on plus energy buildings. They started back in the 90s with some very first prototypes of single family house. Then in the 2000, we started to have multi-family buildings with a positive energy balance. But the challenge was still when we started the project to make to lower the overall cost of these buildings, and to demonstrate them and to demonstrate the concept in 4 case studies among Europe. And next slide, please. In order to do that, we defined or we based our design on 7 key principles that you can find also well described in the design guidelines, which are available and accessible through this QR code and on the PEB HUB as well. So first, to create spaces, to look at comfort first and create comfortable and healthy spaces. Then we try to align building design and the technology configuration with the residents' needs using a social practice approach. Of course, look at the size, the production in order to match the energy consumption and to lower as much as possible the energy consumption. Optimize the use and most of all the storage of renewable energy. Use building flexibility to maximize the energy self-sufficiency, minimize greenhouse gas emission, and keep the cost affordable. So these were our 7 key design principles. I won't go that into much detail because we held the final project event last month, and if you go to the next slide, you can find the recordings of the final event, and there's a full presentation on the design guidelines, and you can also access them directly through the link that is on this slide and on the PEBHUB, of course. I think, yeah, these are a really nice outcome for the project because it kind of summarizes all of our results. And in case you want to get more insights or have an in-depth analysis of the results, there are links to specific project reports and deliverables that you can access, so they're publicly available to get more details. Give the micro to Beatrice back now to present the PEBHUB, which is why we are here today, right?
Thank you, Ana Maria. So as we are saying today, we are here, to actually present you the Plus Energy Building Hub, right? So this repository and community are dedicated for advancing Plus Energy Building design, and the way we develop it is with the designers in mind, but also, so not only architects and engineers, but also other researchers, technology providers, so all PEB professionals who can benefit from having access to this type of information. So maybe one of my colleagues can kindly add the link to the chat, but you can also access on your mobile phones the repository with this QR code. Before I go into the platform, and guide you through the platform, I will give you an appetizer of the things that you will be able to find in the PEB Hub. So we've been collecting, working together with designers, different real-world examples of Plus Energy buildings. And we've been gathering data on energy performance data, building technologies, some envelope innovations, all these climate adaptive designs, and as well cultural and climatic considerations. So these insights made this repository stand out because this is something that designers, even if they should take it into account, sometimes these cultural and climatic insights might go a bit under the radar. So I think this is something that, as the name of our project culturally indicates, is something that we've been having very much in our minds. So this is something you will find in the PEB Hub. You can also see the design guidelines very much in detail, as Ana Maria was explaining. And then we have like this section on tips by designers for designers, where designers share their best practices, but also worst practices, so that other designers can learn as well from their challenges, right? And finally, you can also find a simple and interactive quiz, which is meant for the general audiences. And this is meant to raise awareness on the benefits of Plus Energy buildings, right, and their importance. So if you are curious to see if you know a lot or little about Plus Energy buildings, I assume quite a lot since you are here, you can also take this quiz. And now I will go to the platform and we'll show you how it looks like. So basically, we have like different tabs here, right? Plus Energy buildings. What is a Plus Energy building? Design guidelines, join the community, and about. And I will today click on one of the Plus Energy buildings to showcase how it looks like, right? One of these PEB cases. So here we have a short description of the building. So information on the architect, owner, building gross net area, net area. So all this type of useful information, some photos that will give you, an impression on how the building looks like. And then we have different sections, right? The technology solution sets on heating, cooling, ventilation information. So here you can see different photos. You can click on them, make them bigger. So it's quite user-friendly. And then you have information on the different building technologies, the type of systems, decentralized, centralized, the technologies that are installed, the different distribution systems, and sometimes also information if the designers have provided to us on the manufacturers, companies they've been working with, and consultants that they've used. So this, if you are wanting to build a PEB in, let's say, southern France, you can also go and check in the PEB Hub if someone has already uploaded a PEB in that region. Then we have information on renewable energy production. If if you have electric storage batteries, photovoltaic rooftop systems, like in this case, and then also information on the building envelope. So you can click on wall, roof, window, and then you can see the different U values, the different materials that have been used, so that you can, and a short explanation, right? So that you can have an idea on what these designers took into account in this PEB. And finally, we have like this culture and climate section where you can see different, if you click here, so different practices such as heating, cooling, cooking, cleaning, ventilating, how, for example, considerations about mechanical ventilation, some design features in order to generate this surplus of energy. And these are all things that the designers themselves have been answering. And you can understand a bit better what are the design trade-offs that they've been making in order to maximize energy efficiency while also attending to the user's comfort. And the last section is what I said before. So these PEB tips for designers by designers, what you can find advice on building technologies, on external services that they might hire, like a consultants, or like, for example, a certification process, if it was compulsory, for example, in that region, different tips on cost optimization, and so on and so forth. And then you can go and navigate and see other Plus Energy buildings, right, that are in the repository currently, and go and explore other regions, other challenges. And if we scroll up again, this is where you can find the quiz that I referred to before. I'm not going to go into detail now, but this is the tab that you can click on and just play around and navigate. And if you want to join the community, if you are a designer yourself, you can contact us directly, or you can fill in this form and we will be in contact with you shortly. And I guess I will go back to the presentation now. If you have any questions, please type them on the chat and we will go through them as well during the Q&A. I will leave the floor to my colleague Marta, and she will be guiding you through the ACE Hub.
Thank you, Beatrice. Good morning, everyone. I'm Marta Cambidi from the Architects Council of Europe, and in the Cultural Project, we are the communication and dissemination leader. Today, I will present you the ACE Hub and how we are trying to engage it for the creation of a plus energy building community. So what is the ACE Hub? The ACE Hub basically is an app, and it works like a social media for architects, with the aim to connect architects through Europe through professional networking, knowledge sharing, and giving them the opportunity to be up to date with the latest events, projects, and activities in the architectural world in Europe. Now I will share with you the platform, so you can have an insight of how it looks when you create your own profile. Basically, this is the home page. You can see everything. You can scroll down and have a look. the resources and all the activities, basically. And then you can navigate through the menu bar. For example, here we have the matchmaking and networking. Here you can find all the collaboration opportunities, the job and internship opportunities, and the user directory. Here, actually, through keywords, you can look for a specific person, for a specific association, or for a specific topic and try to connect. Then you have the news and resources sector. Here, basically, you can see all the news, the latest publications, the latest architectural project, and in the multimedia, you find insights, speech, like parts of conferences that deal with architecture. In events and activities, again, you can find an event calendar. Let's see if it works. Yes, with, for example, the planning for the month of March, and you can filter also the activities here for upcoming events and past events. And then we come to the interest groups. Basically, as I was saying, this works as a social media. So what we were trying to do with EURAC and RMIT Europe is to create a specific group for plus energy buildings. As you can see, for now, we have 6 groups that target specific topics, and one of them is plus energy buildings. So the idea here is really to gather the community of professionals that work in the plus energy building sector. So not only architects, but designers, in general, technology providers, and to connect them. Because the interesting thing here is that you can see the users of the group and get in touch with them. You can publish some new topics that you have found. For example, if you look here up on the right, you have this plus button. And if you have an interesting topic to share with other people, you can create it and they can interact with that, answer to you, look for you, and you can receive directly messages and emails. And whenever you have a notification, for example, it will come up here. So whenever someone puts something in the interest group, you will receive it, actually. And this is really the idea of sharing the news and making people connected through this network. We can go back, I think, to the slides. So as I was saying, that it works as an app. Here, if you scan the QR code, you can have access to this online version that I just showed you. Otherwise, you can download it on your phone, on Google Play and on the Apple Store. If you have any questions, again, you can write them in the chat and I will be happy to answer you. And I think I can give the floor back to Beatrice to keep on with the webinar. Thank you.
We are very, very, very good with the time, and we are ready to jump into the panel discussion, which is also one of the main protagonists of today's webinar. So we are going to hear from first of all from Ringo Offerman and Herman Leys, and we will be having like these presentations around these questions, right? So what are the main challenges that you've been facing in the design of your plus energy building, and also what lessons have you learned that you can share with the designers community? So I will give you the floor, Herman, Ringo, so that you can also start.
Okay. Thank you very much, Beatrice. Can you hear me?
Yes.
Okay, very good. So my name is Ringo, and Herman, my colleague or engineer, here, there he is. He's been our consultant who has devised the energy concept for this building. So we do have the honor to present you this German demo case, as it says here, the project, a residential building in Germany in a town called Ostfildern, just in the outskirts of Stuttgart, which is almost completed. So I'll give you a quick overview of the building. Click there. Oops. I go back. Yes. So it's just a rendering of the building that you see here, because completion is scheduled for this summer or May, June. So it's very soon, but it's not completed yet. It is a mixed-use building with a residential part on the top. So on the first, second, and the penthouse floors, we have residential units, 21 in total, rental units, and we have a commercial floor on the ground floor, which is going to be used half for office use, and the other half is going to turns out to be a physical therapy place. So in total, it's a mid-sized building. As you can see, we have 4 above ground floors, and there's 1 underground parking level. In total, we have around 4,000 gross area and almost 3,000 square meters of usable area. And as you can also see on the pictures on the right, it's a wood concrete hybrid construction. The core, the staircase and the elevator core, and the underground level, of course, are built in concrete, but everything else is wood structure with wood columns, wood beams, wood slabs, and some of the load-bearing walls are also in wood. But the exterior walls are all non-load-bearing, but they are all also in wood construction. And yes, next slide. So before I hand it over to Herman to explain the technologies that have been employed to achieve the plus energy building status of this building, there was also, in general, it has a very compact volume. It's almost square, and with the height, so the ratio between the surface of the envelope and the floor area is relatively compact. That was important, but we also know that in urban areas, you very often do not have the control to determine yourself what the geometry of the building is. So we also on this side, it's semi-urban, I would call it. So it's on the interface of a residential and industrial area. There were zoning regulations, of course, in place. So we had some leeway as to determine what the geometry, what the shape will be, but basically we're occupying 80% of the site and the geometry is what it is. But if you have control, of course, the first thing that you would be looking at is to minimize the envelope versus the volume that you're enveloping. And then first step to minimize or to optimize energy. And then we can also talk about the technologies. And Herman, I'll leave it to you.
Yeah, so thank you very much. Hello, everybody. Morning. Can you hear me? Yes?
Yes, we do.
So, okay. So where to start here? So first, technologies. One is to make a good envelope so that we don't. No, you should not jump to this.
You should not.
I'm on this slide. So we did a good envelope with low U values in roof and wall, which is the main envelope. And then for heat generation, we use a central air source heat pump, which is installed outside. And for the generation of electricity, we use photovoltaic panels and a battery. And wooden construction, Ringo is telling some bit more later on. And now I jump to the MAP installations. We have 2 parts because we have mixed use. So one part of the building is for the residential use. Here we have a standard floor heating system. And for ventilation, we use an exhaust ventilation system. Where are the fans in the bathroom and in the kitchen. And the air from outside comes by trickle fans in the windows and in the walls. For domestic hot water, we use fresh water modules per apartment. So each apartment has such a unit. For those who don't know what it is, this is a kind of instantaneous water heater, which is driven by heating water, not by electricity. But the heating water is coming from the heat pump. And in each fresh water module, the drinking water is heated up. So this is a bit not normal, I would say. And last but not least, we have a monitoring and a house management system, which is able to give a user feedback to the user, because user plays a big role in the plus energy and reaching the plus energy building. So this is for the residential use. In the commercial use, we have activated ceilings, so chilled ceilings for cooling and heating. And we have controlled ventilation units with heat recovery. Then to avoid cooling too early in the summer, we install ceiling fans to make a bit air movement around, so that people feel comfortable at a bit higher temperatures. And here also we have a monitoring system. So now, Ringo, you can continue.
Yes. Is it worth mentioning maybe that even though it says cooling, we don't have active cooling, right? We're not, actively cooling.
Yeah, thanks. So now I jump to a point. It's also separate in 3 parts. So we discussed a lot in the Cultural E project. What is the plus? And we have to see that we have different levels of the plus in a plus energy building. And here you see 3 graphs. The left one for the residential, middle one for the commercial part, and on the right side the total of the total building in our case. So this is not in general, but this is in our case. So on the left slide picture, we see that the red one is the energy use for the building, for heating, domestic hot water, ventilation, and so on. And the gray one is the user black loads. And the green one is the energy produced by the photovoltaic system. So this is similar in all 3 slides. And what we see here is that we can easily reach the plus in the residential part, not yet directly in the commercial part, and we can reach also the plus if we have a look on the whole building. So this is concerning the energy demand of the operation of the building. And next level would be we put also into the balance the plug loads of the users, so the tenants or the people working on the commercial area. And if we do it, we see that the produced photovoltaic electricity is not enough to fulfill this plus energy goal. So this is fact. This is fact at the moment. So we reached the plus. We did all we can do to reduce the energy demand in the building. But what the people are doing in the building, so this is out of our scope at the moment. And this has also to do with the limited surface of photovoltaics we can install on the building surface. So, Ringo, can you continue, please? The next one.
Yes.
So here you can continue, Ringo.
So, yes, I can. I can talk a little bit about the challenges that we faced when designing the photovoltaic system. So other energy sources were not really available to us. We looked into wind. It's in this area there was not enough wind to dense, probably also urban. There was not really a source for us. Geothermal, no. And then so photovoltaic really was the only option that we had, meaningful option that we could employ in this area. There was also a so obviously you want to maximize the area and see you are limited by the surface that's available to generate energy to install the photovoltaics. And so obviously the first thing that we looked into was turning all the entire roof 100% into making that available for the PV system. Though zoning could get in the way. For example, in this specific case on our side, in Germany, you are always allowed to add another penthouse level on top if it has 75% of the footprint of the floor below. So obviously every building does that because it adds to the buildable floor. But it also means that the top floor is always smaller than the building footprint. And that was also the case here. The top floor is set back. It's either set back or in this case, we cut terrace areas into the top floor. And we covered that partially, so the available roof area was not 75% as the footprint of the top floor, but actually a little bit more, around 85% or so. We refrained from covering it 100%, meaning covering all the terraces, because that created 2 dark terraces, unusable terraces, and was also not feasible. So we had to find a compromise between what the zoning gave us and how to maximize the surface available for the PV panels. In the top picture, you can see that there was also an analysis done on how far the vertical surfaces of the building could also be activated to carry photovoltaic panels. But the green, the yellow, and the orange, it all means that they have a lower yield. The red indicates that it has the highest yield. And so the surfaces available did not really add compared to the cost that we had to invest to buy those solar panels. It was not really worth applying those on the vertical panels. That's also another takeaway, probably, that in homogenic urban areas, dense areas, there's enough of shadows being cast by other buildings and the surroundings that the activation of vertical surfaces is relatively difficult. At least it was in our case. Yes, and as you also saw in the graphs of Herman before, we are with this surface of PV areas compared with the gross area that we have, we were barely able to meet the positive energy building standard. Meaning, if we had 1 more floor, for example, the height would increase by 1 more floor, we would not have reached that anymore. So there's a direct correlation between the footprint of the building and obviously also the height of the building, how many floors you have. And so the 4 floors here, I think 3 or 4 floors, it seems to be the sweet spot currently with the efficiency of the PV panels. Obviously, the more efficient the PV panels get, the more yield you have, and then you can add to it. But obviously, in a building that has more height, this would not result in a positive energy building anymore with this geometry. When also maximizing the area for the roofs, you're competing with all kinds of different stuff that's also happening on the roof. And obviously, as you're trying to dedicate everything to the PV, there's a lot of coordination. In our case, we relocated the heat pumps not from the roof to side of the building because we had some site available on the ground floor. Otherwise, the heat pump would have eaten away surface for the PV panels. Other uses were not possible, like roof terraces and so on, because it competes with PV terraces. Green roofs, we refrained from doing a green roof in this case because things would not, only specific plants can grow like between the panels or underneath the panels because most of the roof is being covered by the PV panels. And B, though there are plants that also thrive underneath the PV panels, they also grow and need to be subject of constant maintenance because otherwise they start to overshadow the PV panels by growing taller and higher than the PV panels. So it is not impossible. We have other projects where we have realized the green roof in combination with a solar panel, but it comes with it comes with obligations and other duties that factors that you have to factor in. Also, tricky was complying with the safety regulations for fall preventions, as people for maintenance need to regularly access the roof. And initially, we were told we have to keep a distance from the edge of the roof of 2.70 meters, I believe it was, all around to provide a safe area for the operators. And even with the harness system, it was pretty difficult to coordinate the position of the harness positions in regards to the position of the PV panels and not to lose. There was a moment where we were in danger of not reaching the positive energy status anymore because the safety regulations would have killed so many panels on the roof that we wouldn't have gotten there. But luckily, we after intense coordination, we found a way to compile both of them into one viable solution. Third, the efficiency of the PV models is also something that currently is still evolving very rapidly. So when we started the design of this, I think, Herman, we were calculating with 380 kilowatts per year yield with the panels. And I think at the end, at the point where we purchased these panels, we were at 400 something, 420. So there was a natural increase also in the efficiency of the panels, which also, of course, helped us and played into our hand to achieve even more energy with the same design area that we had started with. And last but not least, there's also challenges with the sales of surplus energy. That's maybe your topic, Herman.
Yeah, that's a topic. That's also a big challenge to what to do with the surplus of energy. So we can use it in the building itself. So for the operation, for the heat pump, for example, and all those things. But as soon as we jump to sell it to the tenants, it becomes a bit more complicated because of a lot of technical and especially regulation from law side of view. And there it is only possible if if a third party is getting in the project who is doing this this marketing of power coming from the photovoltaic panels. So this is a topic which is also changing at the moment, but it is still the case that you should involve a third party for the marketing of the surplus, because otherwise it's becoming too difficult for an owner of the building. So that's, I think it's
so Ringo, Herman, this is a kind reminder of the time. We need to finish maybe 1-2 minutes max.
Okay, I was about to say, Patrice, yes, thank you for reminding us. So maybe just a few words on wood constructions. Obviously, wood construction is nice, it's great, saves some CO2, but it still has challenges. It doesn't come as a natural alternative to concrete, reinforced concrete, for example. So there's always still the cost issue. It costs 20-30% more for us than to do it in concrete. Sound insulation between the floors is a challenge. Also to the exterior, you have to add additional cavity walls to the exterior walls. You have to add additional weight, mass to the floors to achieve the sound insulation necessary, even minimum standards by law. We had difficulties with finding products, especially fireproofing products that had the certification to be used, such as the penetration of ducts to the wood slabs, for example, or the drains, which needed some fire certification. And also during the execution of the construction work, we realized that the protection against water is really, really, really important. And that also the application of waterproofing or the first vaporproofing barrier could be a challenge with all the connectors and all the little items that are being installed on the top surface of the wood, because wood slabs are not homogeneous. They come in 10 meters or so. They're not a smooth surface like concrete. They are like 1.50 meter strips, and they all structurally need to work together and so on. So they're connectors every 1.50 meter, for example. And so there was a lot of challenges for the waterproofing guy, something that we learned, something that we'll try to do better next time.
Okay, Philippe, perhaps I can say some challenges concerning the house technology. So what we used in this project is established technologies in the building. So besides the HMS, the house management system, and the app for giving a feedback to the users, so this is new, and this is also a challenge. And all others is kind of standard here in Germany, let's say. And concerning the cost, it's a bit the same. So the house management system and automation system is to come to this level. We realized here in this project, this is costly at the moment. And also another point is if we would introduce feedback to the users via an app, even then there should be some support, technical support, but also a mentoring about what feedback we should give to the user. So this is the question, a cost question, because this is work to do. And then I think there's not so much to say. So I would like to finish here our presentation and give the word to the next project. Thank you very much.
Thank you.
Thank you, Ringo. Thank you, Herman. So I will just quickly give you control, Raúl, Maria, so you can continue.
Okay, so can you hear me? Yes.
Yes.
Yes, thanks.
Perfect. So I'm going to present the next case is from a different European project. It's from the Access project. We are going to present me, Raúl Ciria. I work in the National Renewable Energy Center of Spain as a researcher, and Maria Cantalapiedra that is going to say some things as well, and it's the architect of this building. This building is it's called Palacio de los Miranda. It's in Valladolid in Spain. And as I was saying, yeah, it was part of the Access project. The Access project was a European project funded by the European Commission, trying to bring forward the positive energy buildings and also the flexibility in the technologies and the user-centric perspective. What we did in the 4 demos that you can see there, one demo in Austria, another one in Belgium, another one in Finland, and another one in Spain, was to try new technologies for positive energy buildings like deep geothermal heat pumps or PDPs, or also multifunctional facades in the Austrian demo, and try to test that in a real environment and to see what can we do to activate the different energy flexibilities that there are in the buildings and even more in the positive energy buildings, with all together in a coordinated in a smart user-centric system to manage all the appliances and to manage the energy surplus. That it's something that it has a potential benefit that can be used for by the building. Also, we have also focused on the cost effectivity of these technologies, and yeah, well, this you can see more of this project in the web page. Now, if we go to the building itself, what we have done in the Spanish demo, this is the image of the building that we have refurbished. The building is called the Palacio de los Miranda. It's located in the city center of Valladolid. It is an heritage building that was in a state of ruin before the refurbishment that happened during 2012. There was a minor refurbishment involved in the structure of the building just to maintain the exterior facade and the roof, but all the interiors, the insulation and so on was in a state of ruin. So with this project, we have made the refurbishment of this heritage building into a positive energy building that the uses are mainly residential for the upper floors, and in the ground floor the use is commercial. The dwellings that there in this building, it's a 2 or 3 rise building, because there is 2 floors above the ground floor, and there are 9 dwellings, 5 of them in duplex typology, and it also has a basement with 3 levels with 2 recharging points for electric vehicles. The technologies that we have used for this building is first of all an aerothermal heat pump for the heating and cooling, and also for the domestic hot water. In fact, there are like 3 aerothermal heat pumps that 2 of them are for the heating and cooling, and the other one is for the domestic hot water. We also have a radiant floor that it was tricky to install in some parts of the building because we had some issues with the floor to ceiling height in some places of the building because of well, the structure of the building was already in place, and it was too close to the minimum limit allowed by regulation. So the increase in the thickness of the ground was an issue when installing this radiant floor. We also have a PV system in place in the building, and controlled ventilation with heat recovery to be able to match the comfort requirements of the users, and also try to recover all the energy possible. And we also have a lot of different sensors in the building. We have for every apartment and every room we had temperature and humidity and presence sensor to be able to monitor continuously the comfort of the user and also the presence of the user. And this is used in the energy management system of the building that is divided because there is a controller in each of the apartments, so the users can see what all the appliances and all the systems in the building are doing. They can set also different controls and different strategies for the apartment, but this data is also centralized in the building in a BMS that that merge the data from all the apartments and also of all the appliances of the centralized in the building, like heat pumps and also the PV production with the battery, to be able to orchestrate all the different systems and control it the most efficient way possible. If we go next, okay, the result is that together with all the building consumption, considering the residential consumption, for this case, as we are in Spain, we have a little more of radiation from the sun and a little more generation from the PV. We are able to match or even surpass the consumption, the annual consumption of the building, just with the PV that we could fit in the roof. Actually, we couldn't fit or fill all the roof of the building with PV because the roof was tilted and there were very bad orientations, and also because, well, Maria, we are going to tell a little bit more about it, but the PV panels couldn't be seen from the street or from the outside of the building because of the regulation and the heritage protection regulation. But this is the annual balance, so we are able to achieve a positive energy building with an heritage building, whereas in the German case that I think that Ringo told about before, the user equipment and the user behavior inside the building is a big part of the consumption. Now I'm going to leave the floor to Maria, that is going to tell something more about the design challenges and all the problems that we have faced during this refurbishment.
Okay, thank you, Raul. I will talk about the design challenges we found during the process of the building. As he said before, the building is protected. The facade and the roof itself couldn't be touched. So we could not make any changes on the windows or on the exterior materials. So we had to place all the insulation inside of the building. For that, we used 2 layers of insulation. The first one is the insulation you see on the right of on the slide. It's a very thin insulation which occupies only 4 millimeters, but it has to be placed with air chambers. And then we place the second layer with the insulation on the left, which is quite similar to rock wool. So with this system, in less than 10 centimeters, we managed to set the equivalent to 25 centimeters of rock wool. We also faced some regulation issues. The first one, as Raul said before, we were very limited with the floor to ceiling height. We had in the second and third floor, we only had 2.60 meters to place the heating and cooling floor and the ceiling. And placing these both things in 10 centimeters was quite challenging. So we had to use a special heating and cooling floor for refurbishment that occupies only 3-4 centimeters with the finishing. We also had some difficulties placing the PEBs on the roof, as he said before, because they cannot be seen from the street because of the protected building itself. And we also had difficulties placing the external heat pumps. At the beginning, they were not placed on the roof because we wanted to use that space for placing PEBs, but we had to move them there because of the regulation. And this also meant some delays on the process of the building. We also face some difficulties with facilities, as we will see later, with the integration of the different devices and the complex energy system that has been installed in the building. Next, okay. So we also face some challenges if we talk about implementation of the different technologies. We had many difficulties to find installers because they are not quite common here in Spain, and this was a very tricky thing because they were not specialized, and we had to make many changes. And once everything was set, we have found a lot of difficulties also to find a company to maintain the whole energy system. There were companies that could offer the maintenance of some parts, but it was very difficult to find only one to like maintain the whole building, not only the building facilities themselves, but also the control system. And this also had another problem, which is obviously the cost, because the maintenance is a bit higher than that the usual cost for buildings here in Valladolid. With the equipment integration, we also had some difficulties. The engineer team that made some prescriptions with the devices that has to be installed in the building. But during the construction phase, we had to change most of them because although they communicate to each other with different gateways, they had to be changed to try to simplify and to make sure that everything was working or was going to work better. And this also led to some delays in coordination. And of course, using technologies that are not familiar here in Spain also raised some distrust with the commercialization process. It aroused a lot of interest in the city council, in the Chamber of Architects, with architects in general, also with final users. But at the end, they are not very confident with the solutions. In fact, yesterday one user called me because they were not sure if the heating and cooling was working. We checked everything because everything can be controlled through the BMS. We told her that everything was okay, but she was quite unhappy. And today morning she called me because everything was working properly and the house was almost warm as she wanted. But yesterday I was a bit concerned. Next slide, please. Okay, so we learn a lot of things through the whole process. Here we just put the most important ones. The first one is that positive energy buildings can be achieved for heritage buildings. But as our colleagues also said, it's very important to give support to end users, because it makes no sense to make a very efficient building with the best technologies if they don't make conscious and reasonable use of the technologies. For us, also considering the figure of system integration is crucial, because as I said before, it was very complicated to coordinate everything. The energy company said one thing, the research center wanted a different thing, the installer wants to make a different one, and having a figure that can coordinate and can understand about everything, I think it's very, very important, at least here in Spain. And as said before, also to form the workforce with the novel technologies here, I think it's also crucial. And of course, as I think it happens with all projects, we need to expect some delays because to fulfill with the timing, it's always a very difficult thing. So I think, yes, this was the whole presentation.
Thanks a lot, Maria and Raul, for this insightful presentation and being so honest about your challenges. And I'm very much aware of the time. So we are 1 minute past the time. So we will stay 10 extra minutes for those of you who can stay, and we'll have somehow a discussion if you would like. Let me take control again. So I see no questions on the chat, but if you have any, please raise your hand or turn on your camera and please ask your question. I see in the audience some familiar faces, some of the designers that are already populating the PEB Hub. So please, Oliver Richte, Oliver Scholt, Luis Torres, Evian. I mean, I know that you've been going through the process of filling in the questionnaire to get your Plus Energy Building in the PEB Hub. So any feedback, any questions on the presentation of Ringo, Herman, Maria, Raul will be welcome. Okay, Maria.
Yes, can I ask you a question, Ringo? It's about the solution of your building, because the U value you got from the roof is a very good number, and I am curious about how you managed to reach that value.
Yes, sure. So, well, it's relatively conventional. The roof is a wood slab. It's I believe it's only 12 centimeters, but then there is 35 centimeters of EPS on it with the conductivity of 0.35, so standard insulation, but it's 35 centimeters. And for the wall, since we have a wood structure, we have a wood stud system, and it's 22 centimeters of insulation in the wood system. And then on the interior, we have another cavity wall with an additional 80 millimeters of mineral wool. So yes, that's how it all adds up, and that's how we achieve the U value.
Thank you.
You're welcome.
Great. I see there is another question from Elena Laina.
I would like to ask in the last presentation, how did you manage to do the heating and cooling radiant floor? I mean, didn't you have any restrictions in the floors? Because usually in buildings we have in Greece, heritage buildings, we cannot touch the floors, we cannot touch the ceilings, and we rarely can touch the walls. So how did you manage to do that? Because in the floor there are some special ceramics or things like that. Thank you.
When we entered the building, only the structure was left, so we didn't have any floor finished. So we could place the heating and cooling floor, and also the walls were protected from the outside. In one part of the building, there is like a big stone portrait, which is also inside of the building, and we didn't put insulation on that because it was not a permit.
Okay. Thank you. That was a question. Thank you very much.
Thank you, Elena and Maria. Ringo.
Yes, also another question for Maria. So when you applied the interior insulation, in these cases, usually you have a vapor barrier or something, right? So that the moisture does not get to behind the insulation, and there's some condensation, and that restricts also the installation of, I don't know, electricity sockets and so on. Did you have any, what were the difficulties that you encountered with applying a interior insulation?
We found difficulties because the insulation we used is not common. It's from Actis, is the brand of the company, and the first layer, that is the very thin one, has to be placed with wood racks on vertical. Then you have to place the insulation. This insulation has the barrier, water barrier, and this was. I mean, it's not difficult itself to be placed, but people are not used. So it was at the beginning it was a complete mess, but after trying several times it went well. But at the beginning it was very complicated. And the other one, the let's say like the second layer, the one that goes more inside of the building, it's quite similar. It's not rock wool, but it's quite similar, and it can be like pushed to place all the electricity system.
I see. Thank you.
Great. Are there any other questions from the audience?
There is a question in the chat, Beatrice.
Oh, great. Yes. So Linda, if you can also, if you feel comfortable, you can also turn on your camera and raise the question yourself.
Hello, I'm not sure if you can hear me. I have this new device.
Yes, we can.
Oh, great, thanks. No, thank you. It was a very interesting presentation, all of them. I was wondering whether for achieving energy plus building, what is the role of actually mixing the building use and typology, especially in consideration of the optimizing the use of renewables? I was wondering whether this was a consideration at all, especially looking at the German demo that was physiotherapy plus residences above.
Yes. Well, for the German demo, I have to say we had to do a mixed use. It was per zoning. We had the parameters that 2/3 is residential and 1/3 is commercial. And since we usually develop only residential buildings, so actually it wasn't easy for us to accommodate something commercial on the ground floor. As a matter of fact, actually, we're moving in ourselves, our office into the ground floor. But yes, but as Herman's presentation has also shown, the energy consumption for the commercial area is usually much higher than the residential area. So to achieve a positive energy building, with Herman's result, it seems like a 100% residential building would actually be easier.
Thank you, Ringo, and thank you, Linda. Herman, please.
I wanted to add, if I can, that it is also interesting to mix the uses because in this kind of buildings you have a very big surplus of energy in the sun hours of the day. So, for example, if you, depending on the use case of the users, but depending on the hours they go to the building, there is a good overlap between the consumption of the commercial cases or the commercial users and the residential users. So I think it's favorable to have this mixed use to be able to take advantage of this extra generated electricity. But as Ringo said, commercial users consume a lot more than residential.
Any direct comment to Raul's remark? I guess, yeah. I mean, Herman.
Yeah, that's right. I totally agree with this. But we had this. I think we should a bit widen our view and not focus on the building itself, so then include also the neighborhoods. And as soon as we do this, we make the mix. We can make such a mix also if we have a residential building itself, if we have commercial use around in the neighborhood. So this is also depending on the structure where the building is situated. So both can be work together. So that's what we worked also in the Cultural E project, that we do not stop at the site limit. Anna Maria?
Yeah, I totally agree with you, Herman. I think positive energy districts are somehow easier to reach as balance compared to the building level, because especially if you mix buildings with different uses and with different let's say consumption patterns, so that you can consume more on site of the energy produced by renewables, let's say.
Great. I think we are arriving to the end of the webinar. If there are there any?
Beatrice, one more question in the Q&A,
Yes.
not in the chat.
Okay, let me check there. Thank you, Shabna. It's loading, so yes. So we have a question from Di Marco. So look into results. Is it more efficient thermal storage or electric storage in batteries from, PV panels? Any, Raul?
I can try to answer this. So the thing is, I mean, for efficiency per se, if you are not going to use the thermal energy that you stored soon, it's more efficient to use batteries. The thing is that when you have the biggest surplus of energy is typically during the summer months or the hot period of the year, and then you can do some thermal storage. I mean, depending on the thermal storage you are talking about. If you are just talking about inertia tanks that can last about a few hours, it's good to have that, but you need to cool, to store that thermal energy. You have to cool the water before the hot hours of the day. That's where you have the generation of the PV. So in terms in the annual balance, it's more efficient normally to have these batteries. The thing is that it's not very cost efficient. I mean, you can't scale the electric batteries a lot, or because it takes a lot of space and it costs a lot of money. So you have to you need to have a balance between the optimal level of the cost of the batteries that you are putting in the building and the amount of the efficiency or the amount of energy that you are self-consuming in the building.
Thank you, Raul. I hope that clarifies your question. And I guess we are reaching the end of the webinar. You see here on the screen, these are our email addresses, so you can contact us if you have any questions. And we are still gathering, and we will continue gathering after Culturally finishes PEB cases. So if you are a designer and would like to showcase your plus energy building in the PEB Hub, we are happy to hear from you and to bring you on board. And also, as Marta was saying, so the ACE Hub is also starting at the moment, and we are starting to populate those discussions. And I think today was a nice example of how designers can profit from this dialogue, right? And these exchanges, and learning from each other is always something meaningful. So I thank the speakers, I thank the audience, and if are there any final words from your side, we can leave it here. Thank you very much. Yes, see you in the PEB Hub and around. Bye-bye.